Hello everyone and welcome to the start of Unit 10. We're looking today at systems of equations. I want to actually have you turn to page 6. We're going to skip the beginning stuff and save that for class. I'm going to get right in how to solve these. Some of these problems take a little bit of time to solve. Not that they're necessarily difficult, but time. So we're going to look at, starting right on page 6, exercise number 1. This is an easier one for you as it is only 2 sets of systems of equations. And if you see here in exercise number 2, we're going to get to 3. So let's start off with 2. There's 2 ways you learned in algebra, to do by substitution or by elimination. So this one we're going to use a substitution. Now substitution means that you have to solve for one variable and then plug into the other equation. So which one do you want to solve for? Well, y looks the easiest to solve for. It's already by itself. The coefficient is 1. So I'm going to say y equals negative 7 minus 2x. Now what I'm going to do with that is y equals that. I'm going to take this and plug it right into y. And so what I said, I solve for one variable and then I'm going to plug into the other equation, the one that you did not solve for. So I have 3x plus 2 times negative 7 minus 2x equals negative 9. Distribute the 2. You can combine the 3x and negative 4x to make it negative x. I'm going to also add 14 just to save time here to get us 5. And so x is going to equal negative 5. Now, that's one part of the answer. You're not done. You need to solve for y. I'm going to plug that back in here so I know that y equals negative 7 minus 2 times negative 5. That's negative 7 plus 10. I know I'm going fast with the arithmetic portion of it. You can pause it and slow it down if you need to. Y equals 3. And therefore our final answer is negative 5 comma 3. That's our answer. I write it as a point, x first, then the y. So that's substitution. Solve for one variable, plug into the other equation, and you can solve for that specific variable and then get the other variable. That you have done before. By elimination, what you need to do is multiply by a number so that one variable is eliminated. So we have to choose here. You've got to choose the variable. So 1, choose variable. What we're going to do is, again, I think y is the easiest one to look at. So I'm going to choose y. 2, multiply. So both have same coefficient. 1 negative, 1 positive. Why? So they can cancel out. So, the first one, 3x plus 2y equals negative 9. I'm going to multiply this bottom one by negative 2. Why by negative 2? So I can get positive 2y to become a negative 2y. Negative 4x minus 2y equals 14. Notice that I did take the negative 2, distribute to all of them, even on the other side of the equal sign. Notice here that they are the same coefficient, 1 negative, 1 positive. So then what you're going to do is do exactly what the sign says. 3x minus 4x. That gives you negative 1x. 2y minus 2y is gone. That's what we meant to do. Negative 9 plus 14 is 5. You'll notice that we had the same thing over here. Imagine that. So x equals negative 5. Then, now that we don't even have one variable to solve for, so there's one answer, you then have to solve for the other one by plugging into either of the original equations. So 3, solve for one variable. 4, plug into original to find other variable. Got to plug into the original. So here we go. Plug negative 5 in. Again, I think the bottom one's the easier. So 2x 2 times negative 5 plus y equals negative 7. Let me erase that and make it so you can read that. So let's try this again. 2 times negative 5 plus y equals negative 7. That's negative 10 plus y equals negative 7, and add the 10 and get y to equal 3. And notice we're going to get the same answer. Thankfully. Better be, since they're the same two systems. And so there you go. The next step is to look at a 3 by 3, one with 3 variables, 3 different equations, and it's going to be a little more difficult to solve. You need to use the methods that we just talked about, elimination and substitution. And I'm going to show you how to do that. The first step that we're going to do is use elimination. And by using elimination, you need to get rid of one of the variables using equations 1 and 2. So the first step here, use elimination to get rid of same variable, using equations 1, 2, 2, 3, or 1, 3. And you're going to do that twice. I'm going to show you here. Now this one's going to be a little easier because it is example 1. So we're going to create a system by adding equations 1 and 2. So 1 and 2. This is 2x plus y plus z equals 15. And 6x minus 3y minus z equals 35. Sorry. And as I said, I'm going to go through this fairly quickly, so you are more than welcome to pause it and see what I'm doing and slow it down. So I just did 1 and 2. 1 and 2 gave us this. When I do 1 and 3, you're going to get that. Notice what happened in both of them. And you should see that the z's canceled out each time. Now I'm left with a new 2 by 2 system. Now you have a 2 by 2 that has only 2 variables, not 3. And you can use elimination or substitution to solve this. I'm going to say this can be multiplied by 4 to get rid of the x's. And therefore I'm left with 8x minus 2y equals 50 minus 8x plus 20y equals 4. And I'm going to get 18y equals 54. And so y equals 3. Now you need to go back. Now we have to solve for x. We solve for y, I gotta solve for x. I'm going to use one of these original equations. Not original, one of the equations I have though that doesn't have a z in it. So I'm going to use the bottom one. It has a little nicer numbers. So negative 2x plus 5 times 3, I know y equals 3, equals 1. Negative 2x, that's going to is 15. I'm going to send it over to get negative 14, so x equals 7 again. I'm moving fast. You can go back and do the math yourself. So now I have x and y. Now I'm going to go back to the original and solve for z. Which one looks easiest to solve for z? Well, personally I think that choice number 1. So solve for z. I think that looks easiest. So 2x plus y plus z equals 15, and I'm going to plug in. I know that x is 7, so 2 times 7 plus y, which is 3, plus z equals 15. And I'm going to get 14 plus 3, which is 17, plus z equals 15. So z equals negative 2. And my final answer is going to be 7, 3, negative 2. Goes x, comma, y, comma, z. And you'll notice that I put all my z's with lines through it just so I don't get confused with 2's here. So moving on to the last example that we are going to do. I wrote here the 4 steps that I use to solve a 3x3 system. I do want to state that I use elimination most likely there, but I already went over these. Choose a variable to eliminate, use elimination method in 3 equations to create a 2x2 system. Use solve for one variable using either method. Again, I use elimination, and find the other 2 variables using substitution. So the last example here. The first thing that we're going to do is use elimination. And just looking at this, I see that I have a y, a 4y, and a regular y. I'm going to eliminate the y's. That looks like the easiest method to eliminate. So you guys are going to do some work on your own here. One, I label these just so you guys know what I'm doing here. I'm going to choose 1 and 3. Why did I choose 1 and 3? Because this has a positive y, this has a negative y. So I'd like you guys to use the elimination method right now and get your one equation from getting rid of 1 and 3. Right now, pause it. So you should get 9x minus 10z equals negative 25. Now the next one that you choose is up to you. I'm personally going to choose 2 and 3 because the y is positive here and the y is negative here, and I only need to multiply by a 4 to get rid of the 4y instead of by multiplying by a negative. So I'm going to use 2 and 3. I'm going to get negative 2x plus 4y plus 2z equals 38. And what I'm going to do here is multiply that by 4. So I'm going to get 20x minus 4y minus 28z to equal negative 76. So take the time to do that. You got 18x minus 26z to equal negative 38. Now that I have a 2 equations with the same 2 variables, we're going to go to B. I'm going to do it over here just so I have room. And put 9x minus 10z equals negative 25. 18x minus 26z to equal negative 38. What I would like you guys to do is pause it, and you guys try to solve this on your own. So pause it. And so hopefully you got z to be negative 2. What I did here was take away try to eliminate the x's by multiplying the first equation by negative 2. It eliminated the x's. So now that I have z, I got to solve for x. And how am I going to solve for x? I'm going to take the negative 2 and plug it back into one of these equations. Which one, it doesn't matter. I think the top one's easier for me personally, so it's 9x minus 10 times negative 2 equals negative 25. 9x plus 20 equals negative 25. Subtract the 20 over, get 9x to equal negative 45. And so x is going to equal negative 5. Now, I've got to still solve for y. So I have z, I have x, I've got to solve for y. How do you solve for y? Solve for y by taking one of the original equations. Again, I think this top one is the easiest. So 4 times negative 5 plus y minus 3 times negative 2 equals negative 6. Again, I got the x value right here, the z value right there. Get negative 20 plus y plus 6 equals negative 6. I'm going to get negative 14 plus y to equal negative 6. And so y is going to equal 8. So my final answer is negative 5, 8, negative 2. I know I went fast. Feel free to rewind. Take your time doing the arithmetic out. Other than that, we'll finish off number 4 in class and look at the beginning of the unit that we skipped. Have a good day.